All right, let's talk about one of the biggest, most fascinating, and honestly one of the thorniest issues in all of AI right now, hallucinations. You know, that bizarre moment when an AI tells you something with total confidence that just isn't true. So here's the big question we're going to tackle. When an AI just makes something up, is that a simple bug we can patch, or is it something way deeper, an unavoidable feature of how these things are built? I think the answer is going to surprise you. Let's dive in. So, we're going to start with a really provocative idea from the research, one that suggests this isn't a problem we can just code our way out of. Okay, first things first, let's make sure we're all on the same page. When we talk about hallucination for a large language model, we're not talking about it seeing things. We're talking about the AI creating an answer that looks and sounds totally plausible, it's grammatically correct, it's coherent, but it's just factually wrong or completely made up out of thin air. Now, get this. This is the actual title from a major research paper on the subject. Notice they don't call it a problem or a glitch. They call it inevitable, an innate limitation. This isn't just some opinion piece. It's a formal mathematical argument. And that claim is actually backed by some pretty heavy-duty mathematical proofs. This table kind of boils down the big takeaways. Theorem 1 basically says this isn't a bug in one model. It applies to all of them, even future ones. But that corollary 1 is the real kicker. It says the AI can't just fix itself from the inside. It can't just double-check its work to solve the problem. It needs help from the outside world. So, this is the crucial mental shift we all need to make. We're not trying to squash a bug. We're learning to manage a fundamental, baked-in trait of the technology itself. It's a feature of the system, just not one we particularly like. Okay, so if we can't get rid of them, we absolutely have to get good at spotting that. So let's create a little field guide. Let's break down the different species of hallucination you might find in the wild. The first big split is between intrinsic and extrinsic. An intrinsic one is when the AI messes up the information you just gave it. You know, you ask it to summarize an article that says a vaccine was approved, and the summary says it was rejected. It's contradicting the source. An extrinsic one is when the AI just pulls a fact out of nowhere that's totally wrong, like confidently telling you about the Parisian tiger, which, by the way, never existed. Here's another way to slice it: factuality versus faithfulness. A factuality hallucination is a simple lie about reality. Thomas Edison did not invent the internet. A faithfulness one is when the AI just goes off script from what you asked it to do. As you can probably tell, these categories can get a little blurry and overlap, which really shows you just how tricky this whole thing is. And the variety is just staggering. It's not just simple facts. AIs can make logical leaps that make no sense, get totally confused about when things happened, and, most worryingly, they can veer into serious ethical territory, like defamation or spreading harmful misinformation. And this is not a hypothetical. This is a real case. An AI didn't just get a date wrong, it invented a damaging lie about a real person, and then, to make it worse, it fabricated a fake news article to back it up. That shows you right there. The stakes couldn't be higher. Okay, so we know what they look like, and we know they're, well, inevitable. So the next logical question is, why? Why do they happen? And is there anything we can actually do about it? The why really boils down to 3 main buckets. First, there's the data. The AI might have been trained on information that's just old, biased, or flat out wrong. Garbage in, garbage out. Second, it can be the model itself, its architecture, or how it was trained. And third, believe it or not, it can be us. The way we write our prompts can sometimes accidentally lead the AI down a rabbit hole of fiction. But this right here is the absolute heart of the problem. You have to remember what an LLM actually is. It's a super-powered prediction machine. It's like a statistical parrot. Its one and only job is to predict the next most probable word in a sentence. It's optimizing for what sounds good, for what's plausible, not for what is true. Truth just isn't part of the equation. So if you can't trust the model's internal knowledge, what do you do? Well, one of the best solutions we have is something called retrieval augmented generation, or RAG for short. The best way to think about it is this. You're giving that statistical parrot a fact-checked script to read from. Before the AI writes anything, the RAG system goes out, finds reliable info from a trusted database, and then tells the AI, okay, build your answer, but only use these facts. It grounds the AI in reality. Now, for our last section, let's turn the camera around, because this isn't just a tech problem, it's a human one too. And then we'll see how the industry is trying to keep score in this ongoing fight against AI falsehoods. So why do we fall for these hallucinations so easily? Well, our own brains are kind of wired for it. First, we have automation bias. We just tend to trust computers more than we should. Then there's good old confirmation bias. We're suckers for any information that confirms what we already believe. And finally, there's this tricky one, the illusion of explanatory depth, which is a fancy way of saying we think we understand how the AI works better than we actually do, so we're less likely to question it. So you've got this baked-in problem on the technology side and a bunch of vulnerabilities on the human side. The industry's approach has basically become, if you can't eliminate it, you have to measure it. And that has led to this fascinating world of public, competitive leaderboards to see who can build the most reliable AI. And here's a great example. This is the Vectara Hallucination Leaderboard. It's a straight-up head-to-head contest that measures just one thing. When you ask a model to summarize something, how often does it make stuff up? A lower score is better, and you can see it's a really tight race to build a more truthful model. Here's another way of looking at it. This index tracks broader reasoning and intelligence. The logic here is pretty simple. A smarter model, one that can reason better, is probably going to be less likely to make these kinds of unforced errors. It's a different way of measuring the same goal, reliability. And this last chart, I think, tells a really hopeful story. Look at that trajectory. Even though the problem of hallucination is fundamental, this shows just how quickly these models are getting more capable. The progress is stunning, and every step up on this chart is a step towards more reliable, more trustworthy AI. So after all that, what are the big takeaways? Number one, hallucination is an innate feature, not a simple bug. That means our goal has to be management and mitigation, not total elimination. Number two, our own brains make us vulnerable, so we can't be passive users. And that leads to the final, most important point. Human oversight and good old-fashioned critical thinking are absolutely essential. They're not optional. And that leaves us with a huge final question to think about. If an AI that is capable of just making things up is here to stay, how do we build a world around it? How do we design systems, and more importantly, our own habits, so that we can get all the amazing benefits of this technology without falling for its flaws? How do we build a future where we can actually trust AI?